Welcome! So today, we're going to break down the syllabus for Computer Programming 2, course code CSC 202. If you've just wrapped up your first programming course, well, this is your next big step.
All right, let's just jump right in with the one question this whole course is really designed to answer. You figured out how to write commands, how to make a computer do what you tell it to. But there's a huge leap between writing a simple script and actually engineering a complex piece of modern software. This course, it's all about building that bridge.
We're talking about a shift from just coding to actually creating. This isn't just about memorizing more syntax, it's about changing how you think, adopting a whole new philosophy for building apps that are powerful, scalable, and, actually manageable in the real world.
And this slide really nails that fundamental shift in thinking. Let me put it this way. Your first course, structured programming, that was kind of like learning to lay bricks, one by one in a straight line. It works for a simple wall, but it's slow. Object-oriented programming, or OOP, is like being handed a set of pre-built, reusable parts, entire walls, windows, doors, that you can assemble into a way more complex building, way more efficiently.
And hey, don't just take my word for it. The syllabus says it right here, crystal clear. This isn't just a different way to code, it's a better way for building serious software. Reliability? That means fewer crashes. Maintainability? It's easier to fix and upgrade down the line. And reusability? That's the big one. The work you do today can be used to solve completely new problems tomorrow.
Okay, so what's actually in this new object-oriented toolkit? Let's break down the core concepts you're going to get really good at. Think of these as the absolute pillars of OOP.
First up, the class. Honestly, the best way to wrap your head around a class is to think of it as a blueprint. It's not the house itself, right? It's the detailed plan that defines everything about the house. How many rooms, where the doors go, the whole shebang. In code, it defines what an object is going to know and what it can do.
So following that logic, if a class is the blueprint, then an object is the actual house you build from it. You can use that one blueprint to build 100 different houses, and each one is its own unique object. They all share the same structure, but each one can have its own data, like a different color of paint or different furniture inside.
Now this is where it gets really powerful. Inheritance basically lets you take a blueprint you already have, let's say for a basic car, and use it to create a new, more specific blueprint for like a sports car. The sports car automatically gets everything the basic car has, wheels, an engine, doors, and you only have to add the new stuff, like a spoiler or a bigger engine. It is a massive time saver.
And finally, we have polymorphism. I know, it's a mouthful, but the idea is actually super simple and kind of elegant. It just means you can tell different objects to do the same basic action, and they'll each respond in their own unique way. You tell a dog object to speak, it barks. You tell a cat object to speak, it meows. The command is the same, but the result is specific to the object. That makes your code incredibly flexible.
And you can see from this timeline how the course builds these ideas one on top of the other. It's not just going to dump them all on you at once. You start with the fundamentals of classes and objects, then you learn how to think that way, and then you start layering on the really powerful stuff like inheritance and polymorphism. By the time you hit the midterm, you'll have that whole foundational toolkit ready to go.
Okay, so you've got the theory down pat. But what good is theory if you don't actually use it, right? So the entire second half of the course is about taking these new, powerful tools and building real things with them. You're going to move way beyond just text on a black screen. You'll learn how to make your programs do multiple things at the same time using threads, and then you'll dive into building graphical user interfaces, GUIs, the windows, buttons, and menus that users can actually see and click on, even adding multimedia with JavaFX.
And every lab, every assignment, every single concept you learn, it's all pointing in one direction. It all leads to one big challenge that brings everything together, the final team project.
And look, this project isn't just about writing code that runs. No way. It's designed to assess you like a professional developer would be. Can you collaborate with the team? Can you design a good solution using object-oriented principles? Can you actually apply things like inheritance and polymorphism to solve a real problem? This is where you prove you can build real software.
All right, let's get down to brass tacks. The question every student wants to know. You know what you're learning, you know what you're building, but how is your success actually going to be measured? Let's break down the grades. So check out the balance here. Yeah, the final exam is the biggest single slice of the pie at 30%. But look at that other massive chunk. 35% is from all the work you do week in and week out, the assignments, the labs, the quizzes. What that means is that showing up and putting in consistent effort is just as important as acing the big exams. And that final project, a solid 15%, so your hands-on skills matter. A lot.
And finally, to make sure everything runs smoothly and fairly for everybody, there are some important rules of the road. Let's cover the key policies you absolutely positively need to know.
Pay very close attention to this number. This is a non-negotiable rule. The syllabus is super clear. There is a hard limit of 30% absence. If you go over that, it's a final dismissal from the course, no matter what your grade is. So rule number 1 is just show up.
Next, academic integrity is a huge deal. The university has a very strict policy, and the syllabus lists out all the things that count as a violation, from the obvious stuff like cheating and plagiarism to things like free riding on group projects. The consequences are serious, so you really want to understand and respect these rules.
And just so we're all on the same page, this is not just an honor system. The syllabus is very upfront that all of your code, assignments, labs, projects, is going to be run through MOS, which stands for Measure of Software Similarity. It's a powerful tool for detecting plagiarism. Your work has to be your own, period.
So when you boil it all down, CSC 2020 is about so much more than just learning Java. It's really about rewiring your brain. It's about learning to see problems not as a straight line of steps, but as a system of interacting parts, of objects. It's a powerful way to think, and it's the foundation for pretty much all modern software. So the only question left is, are you ready for the challenge?